A very good day to everyone. Welcome to our presentation. Our project title is A Mobile Robot to Avoid the Obstacle by Using Android Operating System, which means we can use the smartphone to control the mobile robot. Now, let me introduce our project. The main function of our robot is try to avoid the obstacle during moving, which means it will not to crash the thing and it will when it detect the obstacle, it will avoid the obstacle. And our robot can get the suitable path. Our robot can use the medical, military, and educational. The main focus of our project is try to build something the mobile robot for the children when they can playing the mobile robot and can also use for the educational. The hardware of our mobile robot we can already conduct the PIC microcontroller. The PIC microcontroller is try to as a brain of our robot. It is used to control our robot to try to move or try to send the data from the robot to the computer. And we also use the motor driver to control the motor, try to control the drive force. There are two types of motor, is stepper motor and DC gear motor. The stepper motor can control the angle of the motor, but it's too complicated. And the DC gear motor is directly can use. How we transmit and receive data from the robot to our computer, we use the Bluetooth module, which has 606. The H606 is only slave move, which we can control it manually. The H606 allows us to perform wireless, but the range is within a room. The application we use to build the robot, we have already used the Eagle C program and Android Studio, and also the Visual Studio. The Eagle software we use it to stimulate our circuit, and also we build our PCB layout. The C program we use is to program a algorithm try to control our mobile robot to move and avoid the obstacle. The Android Studio is used to develop a GUI on our mobile phone, and the Visual Studio is try to do the GUI on our computer. The sensor contact in our robot have the obstacle detection is IR sensor and the proximity sensor. The IR sensor is try to detect the obstacle around our robot. When the IR sensor detect the obstacle, it will send the data to our microcontroller, and the microcontroller will react and avoid the obstacle. And the proximity sensor we choose is because this sensor can calculate a smooth path for our robot to try to let the journey smooth. The benefit of our robot is portable and easy to use. Because the main focus of our project is try to do a mobile robot for the children for their educational, which means our project is also simple in construction and easy to repair and maintain. Our robot is try to use the low cost component to contract, so we means our robot can maintain a low cost. Our robot is also low power consumption, more clarity, and not easy to cache because we have the two sensor to try to protect our robot. To avoid the collision of the obstacle, we need to consider a few of conditions, which is EKF, APF, SLAM, build number, and WMI. The development of the view of motor, we have four type of We have 4 types of the wheel of the motor, which is 2-wheel mobile robot, 3-wheel mobile robot, omni-wheel mobile robot, and also the 4-wheel mobile robot. The 2-wheel mobile robot is harder to maintain the balance because when the robot try to maintain the balance, it need to keep moving to find the COG, which is the center of gravity. The 2-wheel mobile robot has conduct the tail sensor, which means it will determine the tail angle, and this sensor will keep track the position of the platform of the robot, which means it will try to let the mobile robot become balanced. The second is the 3-wheel mobile robot. Compared to the 2-wheel robot, the 3-wheel mobile robot has one more supporting wheel to maintain the balance. When the drive force is same for 2-side motor, the mobile robot will go straight away. And the other type is omni-wheel mobile robot. The omni-wheel mobile robot can move in 2 directions and the ability to move harmonically. But this type of mobile robot have poor efficiency due to the direction of wheel is, and this type of mobile robot is too complex. Another type of the mobile robot is 4-wheel mobile robot. This type of mobile robot is same as the differentially still one above but with 2 free rotating wheels for extra balance, which means this type of mobile robot is more stable than the 3-wheel and 2-wheel mobile robot.
Now let me to introduce the other condition for our mobile robot. The first one is extended Kalman filter, EKF. It can collect statistical noise and some inaccuracy. It also can linearize about an estimate of the current mean and covariance. If an alternate way to do it, that is AEKF. It is adaptive extended Kalman filter. It can reduce our error to occur accidents such as crash on the obstacle. It also can adapt automatically to the user motion. That means for user, it can using the controller to control the mobile robot. The another one is APF, artificial potential field. It's used commonly in real-time obstacle avoidance and manage to find out a smooth path for a robot, but it still have a few problems when using the APF. So we figure out another 2 methods to increase the accuracy for APF. That is MAPF, modified artificial potential field, and CBR technique. For MAPF is a set of the virtual obstacle by according the shape of the obstacle detected by the sensor. The CBR technique is a retrieval the similar case from the past to reduce our error. That means the CBR technique can retrieve the similar case or the similar experience from previous. Then we can using the past experience to reduce our error to avoid the crashing on the obstacle. The another one is the SLAM. The SLAM have 2 types. The first type is the EKF based on the SLAM. Another one is a fast SLAM 1.0. It's based for the EKF based on the SLAM. It's based on the bias filter for filtering. The future position of the mobile robot can be predicted based on the robot current position. This is a main point for the EKF on the SLAM. For the SLAM 1.0, is based on the raw black wireless particle filter. But if a bad way, you must doing the sampling, outdeling, and resampling. You need to repeat many times to get the accuracy. For another one is using a WMI to do the path for our mobile robot. For our before our mobile robot go to the goals, we need to know our starting point. Like this, we need to know our starting point for our robot. Then only we can go to the to our target point. It's also prerequisite planning and executing a path is knowing the current position or coordinate. And then now I introduce to our BOM, our build material. In our assignment to building this mobile robot, we need to using two wheel. The wheel is using two wheels because our assignment is using two wheel controller, two wheel mobile robot. One unit of the wheel is 550 ringgit. So when using two is 100. The base is 150. The battery we buy four. One is 20. This one battery can be rechargeable. The sensor is the IR sensor and the PIR sensor. The total price that we use is 400. The budget that we want is 600 to build this robot. For the 200 more is using for miscellaneous. The miscellaneous cost is using if any problem happen, we can use such as the component spoil or the battery spoil and the other method happen. The element that we will use in building the robot. The base of our robot is using the wood or plastic to make. The reason that we choose the plastic and wood is the cost is lost, and this material can withstand longer. And then the other parts, putting the sensor around the robot. The first is using the PIR and the IR sensor. This we can make sure our robot can sense the obstacle in the first place. That means our robot can avoid the obstacle easily. The other part of the robot, we will using the recycled material. So when you're using the recycled material, the cost of our mobile robot will very low. Now I make a conclusion for our assignment presentation. To build a mobile robot, we need to consider many factors like EKF, APF, and SLAM. Why consider this factor, we also need to keep our cost in low. But while we keep the loss in cost, we need to make sure the robot also can avoid the obstacle in some accuracy target. So at last, we will try to use all the concept in this presentation to build up our robot. That's all. Thank you. Thank you for watching our presentation.